All right, good morning. This is Mrs. Dellavecchia coming to you from the classroom on Saturday morning. So we are going to go over the DIA study guide, or basically the Unit 4 right triangle trigonometry study guide. So I'm not going to do these problems. I'm just going to kind of explain them because I want you to be able to still have these to work on your own. So first up, the question is, can these three side lengths make a triangle? So when we talked about that in class, I took a straight edge and we said if that's one side of the triangle and I have two other sides of a triangle, if they are only just as long as the other side, when you go to make that into a triangle, in other words, moving that side up and this side up, unless they are longer than the third side, you cannot ever make those touch. So the bottom line here is the two short sides must be greater than the third longest side. Okay, so your problem is the numbers 4, 11, 12. Let's just take the numbers 5 and 7 and 18. 7 and 5, we're going to add, those are the two short legs, so that would be 12. Is 12 greater than 18? Nope. And so this would be not a triangle. Okay, so you try yours, and that is what you do there. So then the next question, can these three side lengths make a right triangle? So the test there is if the two smaller make Pythagorean theorems true, in other words, it's equal, then we can call it a right triangle. If the hypotenuse is bigger than the two legs, then it is going to be obtuse. And the third question, if c squared, the hypotenuse, is smaller, then this would be an acute triangle. And that is basically questions 2 and 3 together. So to test if it's right, I'm just going to say, and again, I'm going to use different numbers. So I've got 5, let's go with 12, and 16. Just picking something random. So I've got 25. Let me work this out. So the legs are the two shorter sides, so I'm using Pythagorean theorem. Okay. And then I need to see, does 5 squared plus 144, I'm skipping steps here, 12 squared equal 16 squared. All right, so that's just my calculator, 144. Does that equal 16 squared? And I do not know that one off the top of my head, so 16 squared is 256. All right, add up my numbers. 25 plus 144 equals 169 equal 256. All right, so it is clearly not a right triangle. In my example, I would say no, it is not right. It's not a right triangle. And then the next question, well, what kind is it? Well, the hypotenuse is bigger than the legs, so it must be obtuse. Okay, so you try your two, and that's the idea there. All right, number 4, we talked about, I want to make sure my microphone's even on, sorry. Yeah, hopefully it's on. Okay, the next one we talked about the idea that the sine of an angle is equal to the cosine of its complementary angle. Okay, so basically all you do with this is that if sine of 24 would equal the cosine of its complement. So complement is numbers that add up to 90. Complementary angles equal 90 degrees. So I'm going to get that difference, and then a cosine would be, in this case, 66. And I should have used a different example, but I forgot. So there you go. That one is sine of an angle equals the cosine of its complement, or you could say it the other way. Cosine of an angle equals the sine of its complement. And we also talked about in a right triangle, these two angles are always going to be complements of each other because they have to equal 90, because a triangle equals 180, and you've always got 90 tied up in the right triangle, so those angles will always be complementary. All right, no SOHCAHTOA. That is just our memory trick for these three trig functions. The sine of an angle equals the opposite side over the hypotenuse. The cosine of an angle equals the adjacent side over the hypotenuse. The tangent of an angle equals the opposite side over the adjacent side. And that is what SOHCAHTOA is all about. All right, so we got a little word problem. A man is standing on the top of a building looking down at a ball on the floor. The building is 30 foot tall. So we are going to draw a picture here. For my example, I will just change the numbers and have you do it with your numbers. So I'm going to say that in my example, we're going to go with 25 feet tall, and my angle of elevation of the ball is 15 feet from the base of the building. If it is 10 feet farther away, well, let's make sure I don't go crazy here. 7 feet farther away. How many degrees larger? Okay, so let's do it with these numbers. You try it with your numbers. A man is at the top of a building looking down at the ball on the floor. So he's up here. There's a ball on the floor somewhere. The building is 25 feet tall. Find the angle of elevation if the ball is 15 feet from the base of the building. Okay, so here's our ball. So he's up here looking down. So the angle of elevation from the ball looking up is right here. All right, so what do we need? We need we're looking for an angle. So this is going to be an inverse trig function. So we're looking, whenever we are finding an angle, we're going to be using our second key to get inverse. All right, label, first step, label the sides. This is opposite. This is adjacent. Our trig function that uses opposite and adjacent is tangent. So we're going to say the tangent of some angle equals opposite over adjacent. All right, 25 divided by 15 equals 1.6. Nope, I didn't do inverse tan. Sorry, that's just the thing. Now inverse tangent. My bad. All right, so theta equals. Now let me back up. Here's how I entered in the calculator. I did 25. I did divided by. I did 15. I did equals. Then I'm going to hit the second button on my calculator. Then I'm going to hit the tangent button, which is actually giving me what we say is the inverse tangent, okay? So, let's do it again. 25 divide by 15 equals, and second tangent equals, and that is 59.0362, so we're just going to round this up to 59.0362. degrees for this angle. Okay? Find the angle of elevation of the ball is 7 feet farther away. So now the ball is getting moved out here. Let me just do a different color quick like. So now the ball is 7 feet farther away. So now the ball is here. And now we need this new angle. Okay? Well, same idea. The tangent of theta of that angle is going to be equal to opposite, same number, over adjacent, which is, that is going to be 22. All right, so now calculator, 25 divided by 22 equals secondary 10, and we've got 48.65. Better if I had left all these numbers in the calculator, but let's just go with this. This was 59.0 something. So how many degrees larger is the angle of elevation when the ball was closer? So 59 degrees minus the 48.65. We'll do it this way. And that is going to give me a difference of 10.35 degrees. All right. So do you try it with your numbers? Same setup, same kind of work. Just give me some different numbers. All right. I'm going to stop here because I'm not real sure my sound is working. Hopefully it is. But I'll break this up in two pieces. So this will be page 1, and I'm going to come back with a different video for page 2, starting at number 7. All right. So see you in a minute. Bye-bye.